Okay, well, we pick up today where we left off on Tuesday, and that is, I think we had just started with mathematical treatment of measurements. In other words, calculations with measurements. Most of this is going to take the form of unit conversions because that's the kind of thing that we have to do a lot in chemistry and other sciences. And so basically, we'll look at some unit conversions, and then we'll try some examples, and we'll go from there. First of all, when you do unit conversions, you need some sort of standard to relate one unit to another. When you've got a measurement, say 25 miles, and you want to know what that is in kilometers, you need some sort of relationship between miles and kilometers in order to relate those two measurements to each other. And in order to do that, what we use is what are known as equivalence statements. Some examples of equivalence statements can be seen at the top of the page here, where, for instance, 1 kilometer is equal to 0.62 miles, or you can look at it the other way around. 1 mile is equal to 1.61 kilometers. 1 meter is equal to 39.37 inches, so it's just a little longer than a yard. 1 centimeter is 0.3937 inches, or 1 inch is 2.54 centimeters, and so on, and so on, and so on. The conversion factor sheet that I showed in class, and which is posted on D2L, is something that I will make copies of, and I'll make sure that you get a fresh copy of this with any exams that we take in class. And this actually gives a long list of what are actually technically equivalence statements down the left-hand side of the page. When you take them and turn them into a ratio, that's when it becomes a conversion factor. But whatever, close enough. But you can see there are a whole lot of relationships here for length, for units of mass, volume, energy, which we haven't really gotten to yet, but that's quantities might have to measure. Speed, which is interesting because speed or velocity is known as a derived unit. It's a derived unit in the sense that it's made up of 2 or more other units. So for instance, speed like miles per hour, it's made up of a combination of miles and hours. You travel a certain distance in miles for each hour that passes by. And so that's what we mean by, or I guess compound unit would probably be a better term for it. And as you can see here, most conversion factor sheets don't include conversion factors for speed or velocity. This one does. And that can actually make things quite a bit easier when doing conversions. And I'll show some examples of that when we get to that point. Also, this conversion factor sheet gives the metric prefixes and their meanings. And so you don't have to memorize those. You'll have this on test. And in fact, you have it right now on D2L. And so in practice, all you really have to do is know what to do with these values, know what they mean and know what to do with them in order to convert from, say, 1 metric unit to another metric unit. And we'll show some examples of that too. There are some physical constants. Some of these may be useful here in chemistry. Some of them are really more for physics. We'll worry about those when we get to them. And down at the bottom, if you want to learn to speak Greek, here's the Greek alphabet, because a lot of these symbols are used quite often in both chemistry and physics. Just so you know what to call a symbol when you see it, you can look it up here. Or like I said, you can learn to speak Greek. I mean, you can actually, after a while in chemistry and physics, you can actually get to the point where you can actually read Greek. You won't necessarily know what the words mean, but you can at least read them. Okay, so we have these equivalence statements. The equivalence statements within the metric system, like for instance, 1 meter is equal to 100 centimeter. Those are considered exact numbers, and they have infinite significant figures because 1 meter is defined as 100 centimeters. And also conversion factors between 1 English unit and another English unit would be considered exact. So 1 foot is defined as exactly 12 inches, and that would be 12.000 on to infinity, infinitely accurate, infinite significant figures. It's important to remember, though, that conversion factors between the English system and the metric system are not exact numbers. And so you do need to pay attention to significant figures whenever an English metric or metric English conversion is used. When I say 1 kilometer is equal to 0.62 miles, that's not exactly 0.62. It's 0.62 something, something, something. And so that only has 2 significant figures. When I say 1 meter is 39.37 inches, that's not exactly 39.37. It's 39.37 something, something, something. And so that would be considered to have 4 significant figures, and so on. So when we're problem solving, that is, in other words, basically solving problems or doing unit conversions with measurements, we employ what's known as dimensional analysis, or sometimes the factor label method. And it really employs simple algebra. And what we aim to do is make sure that the units for the answer come out correctly. And if the units come out correctly, then the odds are the numbers will come out correctly also. So it is very important to keep track of units and to watch them and make sure they come out correctly. And students all the time want to just focus on the number and ignore the units. And it's a real learning process over time where you have to sort of retrain yourself to focus on the units as well as the numbers. Because like I said, if the units come out correctly, then the number is probably correct also. If the units don't come out correctly, then the number is probably not correct either. So it's definitely something that you need to keep an eye on. And many problems in chemistry and physics really just amount, if in effect, to unit conversions. Units, when you're doing mathematical stuff with them, can be multiplied and divided and canceled just like numbers. And they do the same kinds of things. So like if you take 2 times 2, you end up with 2 to the second power, or 4. Well, with units, it works kind of the same way. If you take inches times inches, you end up with inches to the second power, or square inches. If you take 2 divided by 2, the 2's effectively cancel out, and that's equal to 1. If you take something, if you take, say, inches divided by inches, the inches cancel out, and that's equal to 1. In fact, in that case, the units would completely disappear. It's important to remember, though, that units cannot be added or subtracted. If you're going to, say, if you're going to multiply 2 different measurements together, they don't have to have the same unit. The unit that you'll get out would be just the combination of the 2 units that you multiplied. So if you multiply a unit in feet times a unit in pounds, the unit you get out at the end would be foot-pounds. And that actually is a valid unit of force in the English system. If you're going to add or subtract units, though, you can't do that. The units have to be the same if you're going to add or subtract. So you can take something in inches minus something else in inches, and the units for the answer will be inches. But you can't take something in feet and minus something in inches. That won't work. The units have to be the same if you're adding or subtracting. Just a quick example of how we can do unit conversions is, say, if we have 14.5 feet and we want to know what that is in centimeters. Well, actually, the first step is probably going to be something simple like so if 14.5 feet would be equal to how many inches? Well, in this case, it's actually pretty simple. We have an equivalent statement that says 1 foot equals 12 inches. These are the 2 units we want. This is the unit we're starting with. This is the unit we want to end up with. And so we can turn that into a conversion factor by making a ratio out of it. You could use it as there's 1 foot for every 12 inches, or there are 12 inches for every 1 foot. And which one of these 2 forms you would use in this question would really depend on which direction you're going. If you're going from feet to inches, you'll use one of them. If you're going from inches to feet, you'll use the other one. the reason that we can take these two quantities and put them in a ratio like this and use them in a unit conversion is because of the fact that these two quantities are actually the same. They have different numbers associated with them because they're in different units, but the quantity 1 foot is the same thing as 12 inches. And so if you make a ratio of 1 foot over 12 inches, you're not actually changing the value of what you're multiplying that by, you're just changing the unit. And again, that's because 1 foot and 12 inches are actually the same thing. So if looking at the units, if we have 14.5 feet, and that's what we're given, and we want something in inches, well, 14.5 feet is just a measurement. And it's a simple measurement. And so that's equivalent to basically the numerator. You can think of any number as being itself over 1. So for simplicity, just illustrating how the math works, we can think of 14.5 feet as being 14.5 feet over 1. So 14.5 feet is the numerator, 1 is the denominator. We're going to have to multiply that by one of these two ratios in order to get a certain number of inches. And again, you can think of whatever that number of inches turns out to be, you can think of that as being in the numerator and 1 being in the denominator. So if you look at these two possibilities here for the conversion factor that we want to use, you can see that we want feet to disappear because there are no feet in the answer. And on the other hand, we want inches to be in the numerator of the answer. And one of these two conversion factors will make that happen. If you've got feet in the numerator and you want it to disappear, well, the way to get that to happen would be to multiply by something with feet in the denominator, like, for instance, this. And also, if you want inches to appear in the numerator, then you'd want to multiply by something that has inches in the numerator, like this or that. And so now if we multiply these numbers out, we have 14.5 times 12 in the numerator, and that's 174. And in the denominator, we just have 1 times 1, which is 1. And so you don't have to worry about the denominator at all. And if you look at what happens to the units, same kind of idea as what you're doing with the numbers. We have feet in the numerator here, and we have feet in the denominator here. And so feet divided by feet is just 1. So effectively, the feet cancel out. And you end up with inches in the numerator as your unit. And so we have 14.5 feet would be equivalent to 174 inches. Okay. In terms of significant figures, 14.5 feet, the original measurement has 3 significant figures. 12 inches per foot is a definition because that's a conversion factor of 2 English units. So that's a definition that would have infinite significant figures. And so 3 is the minimum number. Integers like 1 are considered infinite also. So we are limited to 3 significant figures in our answer. And in fact, that's what we came up with. So that can remain as the answer. This illustrates the most basic form of a unit conversion. You're given something, so we'll say quantity given, and you multiply by a conversion factor, and you get the quantity wanted. So the quantity that was given here was 14.5 feet. The quantity we want is the number of inches that's equivalent to that. And our conversion factor was the number of inches per foot. In terms of units, you can look at it as being units given, and essentially that's units given over 1, times your conversion factor, which will give you units wanted, which again, you can think of as being over 1 if it makes it a little easier. And the conversion factor will take the form of, well, if you want to get rid of the units given, then units given must be on the bottom. So they'll cancel out. If you want units wanted to end up on the top or in the numerator, then that's where that should be in the conversion factor. So units wanted. So we end up with units given canceling out, and we end up with units wanted. So essentially, in any kind of a simple unit conversion or any individual step in a unit conversion, it's going to take the form of units given times conversion factor in the form of units wanted over units given, which will give you units wanted. So normally in the conversion factor, you would want the new units to be on top. The units you're going to will be on top of the conversion factor, and the units, the old units, the units you want to get rid of will normally be on the bottom of the conversion factor. And then you get the units you started with to cancel out, and you'll end up with your new units. Okay. So this is what I had written right here. In terms of units, it's units given times units wanted over units given equals units wanted. And the conversion factors, again, are made up from equivalence statements. So 12 inches per 1 foot or 1 foot per 12 inches. Within the English system, again, those numbers are all infinitely accurate with infinite significant figures. In the metric system, again, these are also considered definitions. So conversion factors within the metric system are considered infinite significant figures, but conversion factors between English and metric, like the fact that they're 2.54 centimeters that are equivalent to 1 inch, that's between two different systems based on two different standards of measurement. So that will be a limited number of significant figures. 2.54 would be 3 significant figures, not infinite. But you can still use that relationship as a conversion factor. You can use it as 2.54 centimeters over 1 inch or 1 inch over 2.54 centimeters. Okay, for a lot of conversions, well, essentially, theoretically, any conversion can be done in one step if you know the right conversion factors between the units you're starting with and the units you're ending up with. The problem is that in order to do every possible conversion in one step, you would need access to probably thousands, if not tens of thousands, of conversion factors. And even though that list that I posted on D2L is pretty long, it doesn't have that many conversion factors in it. And so we usually resolve ourselves to getting access to as many conversion factors as reasonably possible, and then just sort of resigning ourselves to the fact that some conversion factors may have to involve more than one step. Like, for instance, where did my sheet go? There it is. If I wanted to know (145 feet, or sorry, 14.5 feet would be equivalent to how many centimeters? Now, if you have the conversion factor between centimeters and feet, if you know, or feet and centimeters, you could do that in one step. And I have a feeling that our conversion factor sheet that I posted on D2L has that conversion factor in it. But suppose you forgot about that, or you're just using conversion factors that you can think of off the top of your head. Well, we can go from feet to inches, which we just did up here. And then we can go from inches to centimeters, because as I just showed here, 1 inch is equal to 2.54 centimeters. So we know that one. And this is sort of what's known as a solution map, or like sketching out the route that you're going to take when solving a multi-step conversion. We have to go from feet to inches, and then we can go from inches to centimeters. So I'm just going to do this again, oh, sorry, it's up here. I'm just going to do this again, just as a review. If we have 14.5 feet, and we want to know how many inches that is, well, we know there's 1 foot for every 12 inches, and that means we're going to use either 12 inches over 1 foot, or we're going to use 1 foot over 12 inches for our first conversion factor. We want feet to be in the denominator, and we want inches to be in the numerator. We want feet to be in the denominator because we want that to cancel out, and it's starting in the numerator. And we want inches to be in the numerator of the conversion factor because that's where we want it in the final answer. Okay, so if we multiply by 12 inches over 1 foot, we get feet canceling out, and we get 174 inches. We can then take that, and that's over 1 if you want to think of it like that, times another conversion factor, and end up with something in centimeters. We know the other conversion factor that we need is 1 inch, or the equivalent statement is 1 inch is equal to 2.54 centimeters. So that's going to lead us to a conversion factor that's either 2.54 centimeters over 1 inch, or 1 inch over 2.54 centimeters. Since we're starting the second step with inches, and we want inches to cancel out, that means we want the conversion factor that has inches on the bottom, because inches starts out on the top. So that would imply the first one down here. Also, we want centimeters in the numerator because that's where we want centimeters to end up. And again, the first one has centimeters in the numerator. So that's the one we're going to use. So 2.54 centimeters over 1 inch. Inches will cancel out, and we end up with centimeters as the only unit. And 174 times 2.54 is 441.96 centimeters. Again, significant figures. Looking back, 14.5, our original measurement. Whoops, right there. 3 significant figures. 12 inches per foot, that's infinite because that's within the English system. English units on top and the bottom, so that's considered infinite. The 174 doesn't matter because that was an intermediate answer, so don't pay attention to that. But also 2.54 centimeters per inch. That is between metric and English, so that is not an exact number. That is 3 significant figures, just like the number we started out with. So we are limited to 3 significant figures for the answer. So 4, 4, and 1 can stay, but the 9 and the 6 have to go. Keep in mind, we need to round this off now because the first number we're dropping is a 9, and that's greater than 5, which means the number before it has to go up by 1. So our official correct answer to the correct number of significant figures would be 442 centimeters. That would be equivalent to 14.5 feet. It's one thing that you can keep in mind to check your answers is that we're doing a unit conversion in problems like this. That is, you're taking the same measurement and you're trying to express it in different units, but the quantity that you're expressing should be the same. 14.5 feet and 442 centimeters are the same distance. So what that means is that if you're going to measure the distance in smaller units, you're going to have a bigger number of them. It's like the relationship between 12 inches and 1 foot. They're the same distance, but inches are smaller, so you've got more of them in that space. Well, in this case, we went from feet to centimeters, and a foot is 12 inches, the length of this ruler. A centimeter is only that much. And so centimeters are quite a bit smaller than feet. And so the number for the answer should be not just bigger, but quite a bit bigger. And so if the unit gets smaller, the number should get bigger. If the unit gets bigger, the number should get smaller. And it did get bigger, and it got a lot bigger. So that's a good sign. We did this example here in steps where I converted from feet to inches and then inches to centimeters. And that is perfectly okay to do. But as depending on how experienced you are with this sort of thing, or as you gain more experience anyway, you might be able to do it all in one step, and there's no reason you can't do that. It saves space on the paper, so you might want to consider doing it for that reason. It also saves a little bit of time because you don't have to write as much stuff down. So you can take your 14.5 feet times your first conversion factor, 12 inches over 1 foot, and you can make sure that the feet cancel out. And okay, if I multiply 14.5 times 12, I will have the number of inches in that measurement. But I'm not looking for the number of inches in the measurement. I'm looking for the number of centimeters. So you don't have to stop and write down the number of inches at this point. You can go right on to the second conversion factor, which is 2.54 centimeters for every 1 inch. And now the inches will cancel out, and you end up with centimeters. And then the number will just be 14.5 times 12 times 2.54, which gives you 441.96, just like it did up here. And then you would round that off to 442 centimeters, just like we did before. So it's really up to you which way you want to approach it, one step at a time or all at once. And like I said, if you have the right conversion factor, you can do it in one step. So if we have 14.5 feet, and we need a conversion factor between centimeters and feet. So let's see what we can find up here. There's inches and centimeters. There's, I think that's meters under the hole punch. In inches, 1 foot is 30.5 centimeters. There you go. We can use that, and we can do it in one step. So your conversion factor is going to be either 1 foot over 30.5 centimeters or 30.5 centimeters over 1 foot. And this is, let's see, we've got feet, which is effectively in the numerator, and we want feet to cancel out. So we want feet to be in the denominator of the conversion factor, which means it looks like we're going to be using the second one. We also want centimeters to be in the numerator. So we want centimeters to be in the numerator of the conversion factor, and there are centimeters in the numerator. So yeah, it's definitely the second one. And so we end up with 30.5 centimeters per foot. You notice feet will cancel, and we end up with centimeters as the unit. When we take 14.5 times 30.5, we get 442.25. Now you might look at that and say, wait a minute, that's not the same as it was up above. That was 441.96. But remember significant figures. This is a little bit different because this was rounded off a little bit differently than these conversion factors were. But when you go back and check for significant figures, you'll find that we have 3 significant figures in 14.5. The conversion factor is between the metric unit of centimeters and the English unit of feet. And so that is not an exact number. That is, in this case, 3 significant figures. So we need 3 significant figures in the answer, and only 3. That means the 4, 4, and the 2 can stay, but the 2 and the 5 at the end have to go. Since the first number we're dropping is a 2, we can leave the numbers we're keeping the same, and we end up with 442 centimeters, which is the same as what we ended up with before. And it's because, again, of significant figures. The 4, 4, and 2 are real. This 0.96 and that 0.25, those were not real. Those are numbers that, our calculator thinks that we know those numbers, but we really don't. And that's because of significant figures. So when you round these 2 results off to the proper number of significant figures, they are exactly the same. So a couple different ways you can do that. Most conversion factors can be done practically an infinite number of different ways. They will often, the different approaches will often have different numbers of steps in them. Like we saw here, you can do it in 1 step if you know the right conversion factor, but you might not, so you might have to use more than 1 step. And in fact, you could map out routes that would involve a lot of steps for even a simple conversion like this one. And that's not necessarily wrong. We usually try to use the fewest steps possible because it gives us the fewest chances for error, and it also saves time and effort. But using more steps than absolutely necessary is not wrong, as long as you're setting things up correctly and using valid conversion factors. How you get to the answer beyond that, using valid conversion factors and setting them up correctly so that the units work out correctly and multiplying the numbers correctly. Beyond that, it's really up to you how to approach a conversion. Unless I tell you that you have to use these conversion factors, you're free to use basically any valid conversion factors you want. Mm-hmm. So that was an example of simple conversion factors. As I said, many conversion factors end up being multiple steps. You can do it in any number of different units. You can do it 1 step at a time, or you can do it all at once. And some of them may involve different numbers of steps. So we could see some other examples that we can work. Let's see. 5.3 kilometers to inches. Okay, so an example of a unit conversion, 5.3 kilometers to inches. I noticed that we're a little over on time on the first segment of the video, so I'm going to leave this for the segment. Oops, sorry. There it is. I'm going to leave that for segment B, which will start in just a moment.